So we're going to look at solving radical equations. And before we do this, we have to look at something called an extraneous root. An extraneous root is an algebraic solution that does not exist. Okay, so we can solve algebraically for this square root equation by undoing the plus. So remember, algebra is just going to be doing the opposite operation. So we're going to get rid of the plus with a minus. Okay, so we're going to isolate the radical. So I'll show the steps here. So I'm going to go x plus 3 is equal to negative 4. Okay, so we're going to subtract 4 from both sides. And here we can undo the square root with a square. Okay, so we're going to undo the square root with a square. Now, remember that there might be a bit of an issue here because remember that the square and the square root are not perfect opposites of each other. Okay, so that's the opposite. Opposite square root is square, but not the perfect opposite. So we're going to square both sides to keep the equation balanced. Okay, and then we're going to end up with x plus 3, and that's equal to negative 4 squared is 16. And then we're going to solve for x. So we're going to undo the plus with a minus. So we're going to subtract 3 from both sides. So we get x equals 13. Okay. Whenever we solve algebraically, we should be able to plug the number back in to see if it actually works. So we're going to test it. Okay, and this is the part where it says check for extraneous solutions. Check solution for extraneous. We need to actually check the answer. And with square root equations, we always need to check. Okay, so I'm going to substitute our 13 into x. So it's going to be x plus 3 plus 4 equals 0. 13 plus 3 is 16. Okay, square root of 16 is 4, and 4 plus 4 is definitely not equal to 0. Okay, so this solution that we found is what we call an extraneous solution. It's a solution that shows up algebraically, but it doesn't work. So this is extraneous. Okay, so what does this look like? So why is it that we get its extraneous root? So if we graph this equation, what we're going to do is we're going to solve this by just finding the intersection of the x plus 3, and we'll make this equal to negative 4. So we'll just graph x plus 3 equals negative 4. So we'll let y2 equal negative 4. And our negative 4 is going to be a line down here at negative 4. Y equals negative 4. Okay, and this is going to be a square root graph. And the square root graph looks like this, something like this. Okay, and it's going to start at negative 3 here. Okay, so when we put in our graphing calculator, we have the half parabola looks like this. And sure enough, there is no solution here. They actually do not, this line does not cross this line, so there's no solution. So why is it that we get this extraneous root? Well, when we undo square roots, we have to use a square. Well, the square function is actually a parabola. But notice that the square root is only half the parabola. Okay, so when we square something, what we're doing is we're actually using the square, both sides of the square root. So undoing the square root with a square, what it does is it introduces the other half of the parabola. Okay, so this is what the squaring is going to do. And in fact, that other half of the parabola will intersect that line y equals negative 4. And that will intersect it at x is equal to 13. Okay, so if we actually look at the graph there, if you just adjust your window a little bit, you can see that if you were to kind of draw the mirror image of that, the other half of the parabola on this graph, you'll see that it actually shows up that it does in fact intersect that y equals negative 4 line. And there it is. Okay, and this is why we get extraneous solutions, is because the square and the square root again are not perfect opposites of each other. Just like when we solved the x squared equals, remember when we solved x squared equals 4, when we used the square root we had to introduce a plus minus. to solve that. Okay, because when we use square root, it's not the perfect opposite. So when we undo the square with the square root, we only have 1/2 of the parabola, but we want both sides of that parabola, so we have to do, though we can't just use the positive side of it, we have to do plus minus to make it a parabola. Here the opposite's true. When we square both sides, we introduce the parabola, and which then introduces a possible solution that doesn't exist. This blue half was never there because it's only the positive square root. Okay, square root only is this part here. But the squaring introduces the other part of it, the parabola, the other half that was missing. And this is why we had to be a little bit careful with when we use squares to undo square roots and when we use square roots to undo squares. It's not a perfect match. So we just have to be aware of that and wary of that and understand there's an adjustment that needs to be made. Okay, so explain why when solving radical equations sometimes end up with extraneous solutions. Well, when we undo the square root with power 2, okay, x squared. Okay, when we undo the square root with a square, we introduce the bottom half of the parabola. And you would have seen it with the plus minus going the other way. So what I'll do is I'll put in brackets here the negative square root, which doesn't exist. Okay, this doesn't exist. Okay, because the original equation was only a positive square root equation. Okay, so that when we square both sides, we introduce that negative possibility that didn't exist, which gives us a possibly extraneous solutions. Okay, so this means that it doesn't always give us extraneous solution, but it introduces a possibility of extraneous solutions. So that's why we have to check. We have to check for extraneous solutions whenever we solve square root equations algebraically.